Welcome, everyone. Ready for another deep dive? Today, we're taking a trip to the center of our solar system. You guessed it, the sun.
It really is fascinating, isn't it?
It's one of those things, right? Like we see it almost every day.
Exactly. It's almost easy to forget just how vital it is to, well, everything.
To life itself. I mean, seriously, imagine life without the sun.
No warmth, no light, no us.
Everything would be just gone.
Poof.
Exactly. And get this, when you look at the entire solar system, the sun makes up, wait for it,
Over 99%.
over 99.86% of the entire solar system's mass.
All those planets and moons and everything else,
Yes, the 1%.
less than 1%.
Wild. So how did this incredible, gigantic star even come to be?
Well, let's rewind the clock. About 4.6 billion years. Picture this. A vast cloud of gas and dust. What we call the solar nebula.
Okay, I'm picturing it, a giant cloud just kind of floating in space.
And it starts to collapse under its own gravity.
Okay.
Spins faster and faster, shrinks,
Yeah,
and eventually
cloud is
into a massive swirling
all
disk.
cosmic pizza dough.
Uh-huh. I like that. So now we've got this disk, and most of the material in the disk gets pulled to the center.
Makes sense. Gravity and all that.
Forms a dense, hot core. And as more and more stuff piles on,
The pressure builds.
oh yeah, the pressure and the temperature of the core become, well, almost unimaginable.
It's so hot it makes you sweat just thinking about it.
Uh-huh, something like that. But here's the really cool part. Under these insane conditions, hydrogen atoms, they start to fuse.
Fuse, like become one.
Exactly. They fuse together, forming helium and releasing just a tremendous amount of energy.
That's the birth of the sun.
The birth of the sun.
And that's what we call nuclear fusion, right?
Right. The process that has been powering the sun for billions of years, it's still going on right now.
It's incredible to think that sunlight we see today, it all started billions of years ago with this fusion process.
It is. And all that other material from the nebula, the stuff that didn't become part of the sun,
It clumped together.
to form the planets, moons, asteroids, all that fun stuff.
So from this giant cloud of dust, we get our entire solar system, including us. It's pretty amazing when you think about it.
It really is. But the sun,
Yeah.
you know, it's not just a giant ball of burning gas.
It's not. I mean, it looks kind of like a giant ball of fire.
I know, right? But there's actually a lot more to it. It's more like an onion.
An onion, what do you mean?
Layers upon layers. We've got the core,
Yeah.
the very heart of the sun. That's where the hydrogen is fusing into helium.
That's really hot.
Really hot. We're talking about 15 million degrees Celsius.
15 million degrees. I need a minute to process that.
It's hard to even comprehend, right?
Mm.
But that heat, it generates energy. And that energy radiates outward through the next layer,
Which is called...
the radiative zone.
So it radiates.
Yeah.
Makes sense. So this radiative zone, it's like the energy is traveling from the core towards the surface.
You got it. Imagine like a really crowded dance floor and the photons, the tiny packets of light energy.
Yeah.
They're bumping into each other constantly, taking ages to get out.
Is it a long trip for those little photons?
It can take thousands, even millions of years for a photon to travel through this zone.
Wow. So the sunlight we see, it's been on quite a journey. But it gets out eventually, right?
It does. And then it hits the convective zone.
Convective zone, what happens there?
Things get a little wild. Think of a boiling pot of water. Hot plasma rises, cools, and sinks back down, like a constant churning.
So that's what gives the sun that bubbling look we see in pictures.
Exactly. That's the convection process at work.
Okay, so we've got the core, the radiative zone, the convective zone. That's a lot going on inside the sun. But what about what we actually see? What about the surface?
That visible surface we see, we call it the photosphere. And it's actually pretty thin, relatively speaking, only about 500 kilometers thick.
Only 500 kilometers. That doesn't seem that thin to me.
Well, compared to the rest of the sun, it's like a thin skin. But it's from the photosphere that most of the sun's light and heat are radiated out into space. And here's another one for you. The sun converts about 600 million tons of hydrogen into helium every single second.
600 million tons. I can't even... Is that even a real number?
It's a real number. That's the power of nuclear fusion.
So what's beyond the photosphere? Is that it for the layers?
Not quite. The next layer is called the chromosphere.
Chromosphere. I feel like I've heard that before.
It's kind of reddish layer,
Yeah.
and we can only really see it during a solar eclipse.
Ah, that's why it rings a bell.
Oh, and it's home to some really cool stuff. We see these massive loops of plasma there. We call them prominences.
Oh, I've seen pictures of those. They look like fiery arches.
Exactly. They can stretch out thousands of kilometers from the surface.
Amazing.
And finally, we have the outermost layer, the corona.
The corona, isn't that... Wait, doesn't it get cooler the further you get from the core?
You'd think so, right. But here's the weird part. The corona can reach temperatures of millions of degrees Celsius.
Millions of degrees, but the photosphere is cooler.
Much cooler.
That doesn't make sense. How can it be hotter further out?
That's one of the big mysteries about the sun, honestly.
So even with all we've learned, there's still a lot we don't know about our star.
There's always more to discover.
So we've talked about the sun's birth and all these amazing layers. What else should we know about how this star works?
It's a dynamic system, you know? It's not just calmly burning away. The sun has a personality. Periods of intense activity.
Right, we touched on the solar storms earlier. They can disrupt our technology.
Oh, yeah. And there's so much more to it. We're just scratching the surface here.
So where do we even begin?
Well, remember those sunspots we talked about?
The cooler, darker regions on the photosphere? Yeah.
They're caused by the sun's magnetic field. Imagine it like a tangled web of invisible lines.
Okay.
And sometimes these lines get so twisted, so concentrated, that they actually poke through the surface.
And that creates the sunspots.
Exactly, like the magnetic field is bubbling up.
Okay, I'm with you. So the magnetic field pokes through and suppresses the flow of heat.
You got it, causing those areas to cool down and appear darker.
So sunspots, they're not just spots.
Oh, no. Sunspots are where the action is.
What do you mean?
They're often the sites of solar flares and coronal mass ejections.
Solar flares, coronal mass what?
Coronal mass ejections, CMEs for short. Some of the most dramatic events in our solar system.
Okay, you've got my attention. What are they?
A solar flare. It's a sudden burst of radiation from the sun's surface. Imagine a massive explosion of energy.
An explosion? Like, how big are we talking?
They can release as much energy as billions, with a B of atomic bombs.
Billions of atomic bombs. That sounds a little terrifying.
It's a lot of energy, that's for sure. Most of it goes out into space, but some of it can reach Earth.
And that's where the problems start.
Potentially. They can interfere with radio communications, disrupt GPS signals, even damage satellites.
Yikes.
But on the plus side, they can also create those beautiful auroras we see near the poles.
The northern lights.
Exactly. So, it's not all bad.
A mixed bag. Beautiful lights, but potential technological hiccups. Okay, so what about those coronal mass ejections? The CMEs. How are those different from solar flares?
Imagine a giant bubble of charged particles being ejected from the sun's corona.
Okay, that sounds a little more alarming.
It's basically a massive cloud of solar material just hurled into space.
And if one of those hits Earth?
We get what's called a geomagnetic storm.
Geomagnetic storm? What does that even mean?
It's a disturbance in Earth's magnetic field.
Okay, but is that a big deal?
It can be. Power outages, disrupted communications, damage to satellites.
So potentially a really bad day for everyone on Earth.
In extreme cases, yeah. They could even knock out large parts of the power grid.
That doesn't sound good. So keeping an eye on the sun, it's not just for science, is it? It's about protecting our technology.
It's about understanding the risks and preparing for them.
So how do we do that? Can we even predict when these solar storms are going to happen?
That's where space weather forecasting comes in. Scientists are constantly watching the sun, looking for signs of activity.
Right. What kind of signs?
Sunspot growth, flares, CMEs. They use sophisticated instruments and models to predict when these events might impact Earth.
So it's like a cosmic weather report.
Pretty much.
That's pretty cool. So we're not just, waiting for the sun to throw a tantrum. We're actively trying to understand its behavior.
Exactly.
That makes me feel a little better. But, it's really incredible when you think about it. Events on the sun, millions of kilometers away, can have a direct impact on our lives here on Earth.
We're all connected, part of this amazing, complex system.
It's humbling and a little scary. Okay, so we've got these sunspots and flares and CMEs all tied to the sun's magnetic field.
Right.
But you mentioned this 11-year solar cycle, too. The magnetic field flips.
It does.
But what does that mean for all this activity? Does it get more intense during the flip?
The sun's activity actually waxes and wanes during this 11-year cycle. We go through periods of high activity.
Like a cosmic roller coaster.
We call those solar maximums. And then there are periods of low activity.
Solar minimums.
Right. And these maximums and minimums, they coincide with the flipping of the magnetic field.
So around solar maximum, We see more sunspots, more flares, more CMEs.
It's like the sun is putting on a show.
And during solar minimum, things are calmer.
Much calmer. Fewer sunspots, fewer flares, fewer CMEs.
So where are we now in the current cycle?
The current cycle began in 2019.
Okay.
And scientists predict it'll peak in 2024 or 2025.
So we're heading towards a solar maximum. Should I be worried? Should I stock up on canned goods and candles?
I wouldn't worry too much. Solar activity will increase, sure. But it doesn't mean we're in for a catastrophe. We've lived through several solar maximums before.
Okay, good. But it's still kind of mind-blowing, this cosmic roller coaster ride with the sun.
It's all part of the adventure. And remember, we're constantly learning new things about our star. There are still so many mysteries to uncover.
Well, all this talk about solar storms and magnetic fields is a lot to take in. Maybe we can step back for a second and talk about some of the more basic things about the sun. I feel like maybe I don't know as much as I thought I did.
It's easy to get lost in the complexities. Sometimes it's good to revisit the basics. Address some common misconceptions people have about the sun.
It's funny, right? We've learned all this incredible stuff about the sun, but there are still so many myths, misconceptions.
That's so true. I mean, you'd think for something we see every single day, we'd have it all figured out by now.
Exactly. Like, I remember when I was a kid, everyone said the sun was a giant ball of fire.
Ah, yes. The classic fire analogy. It's a tempting one. It looks like a giant inferno in the sky.
It does. But it's not actually burning, is it?
Not in the way we usually think about burning.
No.
A regular fire, that's chemical combustion.
Right.
The sun, it's nuclear fusion, a completely different beast.
No flames.
No flames, just atoms smashing together at crazy high temperatures and pressures, creating all that light and heat.
Okay, so that's one myth busted. What else? What other misconceptions do people have about the sun?
Well, here's another one. People think the surface of the sun is the hottest part.
Right, but we know that's not true. We talked about the corona, how it can reach millions of degrees.
Millions. While the photosphere, the surface, is much cooler.
I still remember when you first explained that. I was like, hold on, that doesn't make sense. Shouldn't it get cooler further away?
It's one of those things that still puzzle scientists.
Yeah.
Why is the corona so much hotter?
Maybe we'll solve that mystery someday.
Maybe. Science is all about pushing the boundaries of what we know.
Okay, so what other myths should we bust today?
How about this one? That the sun will explode someday, like a giant bomb.
Oh, I've definitely heard that one. But we talk about how that's not really what's going to happen.
Right, the sun won't go out with a bang, like a supernova.
It's going to become a red giant.
Right.
Yeah.
Exactly. Expand.
Yeah.
Engulf the inner planets.
Including Earth.
Potentially. Not a good day for us if that happens.
Okay, maybe we won't stick around for that part. But seriously, thinking about these cosmic timescales
It's incredible.
makes our everyday problems seem pretty small.
That's one way to look at it. Speaking of timescales, here's another misconception. People think the sun is, well, just sitting there, still.
It looks that way from down here, but you're saying it's not.
The entire solar system, the sun included, is moving all the time.
Moving how? I thought it was the center of our solar system.
The gravitational anchor, but the whole system. It's orbiting the center of our galaxy.
A Milky Way.
The Milky Way. And at a pretty incredible speed, too.
So we're not just revolving around the sun. We're also hurtling through space with it.
We are. It's like a cosmic road trip. And it takes about 230 million years for our solar system to complete one orbit around the galactic center.
230 million years. That's wow. It's amazing to think about all this movement, all this activity on such a grand scale makes our little worries down here seem
insignificant.
Yeah, it's all about perspective.
This deep dive,
Yeah.
It's really been an eye-opener. The sun, it's just so much more than a bright light in the sky.
It's a source of energy, a driver of weather, a timekeeper, a storyteller.
It really is. And you know, the more we learn about it, the more amazing it seems.
Absolutely.
So, I think it's time to wrap up our journey to the sun. We've covered a lot of ground today, from its birth to its future, its structure, its activity, even busted some myths along the way.
It's been quite the adventure.
It has. And I hope our listeners are walking away with a new appreciation for our nearest star.
I hope so too.
The next time you look up at the sun, remember all the incredible things happening beneath its surface, the stories it holds, and the profound impact it has on our lives. Keep exploring, keep questioning, and keep looking up.